Hello everyone, I'm Tianyi and I'm from Louisiana State University. I'm working in Stellar Group and also a volunteer at CppCon 19. And today I want to share a project called hpxMP, which is a modern OpenMP implementation using HPX, and where HPX is an asynchronous many-task system. So Hartman gave a talk about HPX this morning. I hope you all enjoyed it. And so first, let's see a very simple OpenMP program. So here's a pi calculation program, and we just use a for loop to add all the areas together so we can get the result of pi. And this is the code for using for loops, and which is not running in parallel. However, with OpenMP, with a very simple line of OMP parallel for, we can tell the compilers how we want to make the loop run in parallel. So it will utilize as many cores as you have, or how many cores you want to use, which makes things much faster. And GCC and Clan all have their own implementation of the OpenMP, including an Intel. So why we need hpxMP? The reason is many asynchronous many-task systems are fighting with OpenMPs. So, for example, if we want to use HPX and OpenMP in the same scenario, they will start fighting each other, which is causing the performance disaster. So we have some ideas so here is the structure of the OpenMP libraries, which they expose the directives to the users and some OpenMP libraries to the users. And in the system layer, the OpenMP runtime will handle the threading and other things. So using hpxMP, we just simply replace the OpenMP runtime library using hpxMP runtime library, where hpx will handle the synchronization and threading stuff. So for users, there will be no changes for them. And we started the project on GitHub, and we added some pragma supported, which is OpenMP parallel for and OpenMP task. And so OpenMP 5 was released last year, and we are trying to keep up with the most recent standard. So we add the task group task reduction into hpxMP as well. And this introduces how to use hpxMP. So if you have a program written with OpenMP, you simply compile your program with Clang or GCC with no changes. And when you run your program, you need to LD preload the hpxMP shared library so that hpxMP will handle the HPX and hpxMP will handle the threading stuff for you. So, for example, if we have two cores, the HPX will start to operating system thread, and when it sees the pragma OMP parallel, it will create as many as the threads you wanted to create. So HPX thread will be created, and if you have task, HPX will also create HPX thread and schedule those threads onto the operating system thread. So here are some examples, and so we have a parallel for loop which prints all the hello world from different threads. Since I'm telling the system we are using two threads, so half of the loops are performed by thread 1 and half of them are performed by thread 0. So a different thread is selling hello world is printing hello world. And because OpenMP is about parallel computing, so the performance is pretty important. And we tested it using BlazeMark and some Barcelona OpenMP task suites. So we discovered that for small grain size, we really have some work to do to improve the performance. But for larger grain size, we are pretty good at it, and we are actually faster than the GCC implementation, but still slower than the Clang implementation. So here's the acknowledgement and my contact information. Thank you all for coming.